loud. Here we go. Okay, so, okay, what's the boy doing? Come here, Matthew, if you've got a boo-boo. Guidelines for factoring. You can find the book's version is at the beginning of the integrated review. So this is page 343. So if they write it out a little bit different, which they will, don't worry too much about that. But basically we want to break down any and all factoring problems into a few common steps. And the very first one, because it's easy to start jumping ahead of ourselves. That's pretty good. We want to check for what I've been calling an overall greatest common factor. And if we find it, we're going to divide it out. That's the very first thing you do before you get dragged down into more detail about the problem itself. The second thing that you'll do is count the terms. And generally, we work with polynomials that have 2 terms, 3 terms, or 4 terms. Generally, that's about as far as we're able to get into it. But you don't want to count terms until you have pulled out that overall GCF. Okay, so count terms, and then there will be, I kind of like the way they do this. There will be, let's go to A, B, and C, like subheadings under here. Working kind of in reverse order from the way we learned this. But it makes sense because let's talk about the simplest number of terms. 2 terms. We learned what to do with 2 terms last, but I'm going to put it first here under our guidelines because 2 is a smaller and simpler number. Okay, so 2 terms, 3 terms, or 4 terms is what we're going to be dealing with. Okay. 2 terms. Yeah, trying to think if I want to organize myself the way they do. I want to add a little bit more detail. Okay. See if I can fit. Four things. Okay. So the possibilities for 2 terms we have are probably what will grow to be everybody's favorite, something in the format a squared minus b squared. This is about as good as factoring gets. Even though you have to memorize this, it's very quick, very simple. And I am going to put an extra thing under here. The 2 terms are where we have to memorize. Unfortunately, they're simpler in one sense and more complicated in another. Okay, so a squared minus b squared, factors like this. However, a squared plus b squared is prime, which means it can't be factored. So prime just simply means not factorable. You could use the word prime if you want, or you could just say not factorable. And then we get into our difference of 2 cubes, and closely related to that, the sum of 2 cubes. So these 2 formulas, thankfully, because if there's anything good about this, we want to find it. Thankfully, the positioning of the A's and the B's stay the same. So I'm going to write A's and B's up here in their parentheses without any pluses or minuses separating them quite yet, which is hard to fight the fight the urge to start putting them in there, but I want us to focus on what's in common. So in the first set of parentheses, there should be an A and a B, and they'll be separated by some kind of plus or minus in a minute. And then in the second set of parentheses, there should be an A squared and then an AB in the middle and then a B squared. So you can see there's kind of a symmetry there to how this works. Okay, and the cube, the A cubed minus B cubed, A cubed plus B cubed, I think I put in the recording last week that those are often called the SOAP formulas. And SOAP being this is a memory device, and it stands for same, opposite, always positive. So same means if you start out with A cubed minus B cubed, the first thing you see is a minus, so you want to match that with the same sign here. If you start out with A cubed plus B cubed, you're going to start out with plus. That's your same sign. It matches what you were given in the original problem. And then the O for opposite means that as you work your way down the line, if you wrote a negative first, you have to write a positive next, and vice versa. And then the AP, those two are linked together. That is always positive. And it just means that at the end of either formula, you're going to have a plus B squared both times. It doesn't matter how the problem began. Okay, so in one sense, the cubed formulas are kind of unfortunate because they require a pretty hefty chunk of memory work on your part. But on the other hand, it could be a lot worse. At least there's some patterns, and at least there's sort of a helpful memory device. So, excuse me. I'm not sick, at least I don't think so. One thing that can trip us up, excuse me, goodness, I'm jinxing myself here. The weather turns cold and just all kinds of stuff happens. It's easy to be confused with the fact that A squared plus B squared is not factorable, but that A cubed plus B cubed is. So that's a really easy pitfall to kind of trip over. So be aware of that. Okay, so two terms. That's where if you're a flashcard kind of person, you might want to make some flashcards. I waffle back and forth personally between being a flashcard kind of person and being the kind of person who really memorizes a little bit better if I actually write stuff down instead of just looking at flashcards. So I think the farther I went into my education, I steered a little bit more away from flashcards, but I would have this technique where I would, you know, at the beginning of like a homework session or a study session, I would just practice writing down the formulas, maybe multiple times, maybe right before each problem where I'd need them, just so I could kind of get that muscle memory of actually writing them down. So everybody's a little bit different in terms of how they like to store stuff in their memory banks. Okay, three terms. This is where, well, let me temporarily skip down here. Four terms we called the method for four terms factor by grouping. And again, I'm putting that word try in there because this is not, I wouldn't do this to you on the test, but I can't guarantee that as you're sifting through problems, studying for the test, you won't come across one, as we have in the past, that it looks like it should factor by grouping, but it doesn't. So at least try that, but just know that it's not necessarily a bad thing if you aren't able to succeed with that. And then three terms, again, I was taught to call what we were doing the AC method. Your book doesn't use that, but it does draw the helpful connection that what we're really doing is applying factor by grouping. We're expanding our three terms into four terms, and then factor by grouping. Three-term factoring is probably the longest of any of these methods that you'll encounter, but because it's the longest, we actually practice it the most. So odds are you might actually come to feel more comfortable with three-term factoring than with these memorized formulas for your two terms. So I don't know. I'm trying to dig for something good in the middle of all of this. So basically, if you want to think of factoring as two major steps, those two steps are dealing with an overall GCF and then counting your terms. And counting your terms will pretty clearly reveal how you should attempt to proceed in the problem. So the book, I'll add this to my notes. The book includes more detail because they wanted you to memorize more formulas than I did. The book really wanted you to recognize things that fit this format or that fit this format. And I believe I threw a little bit of that into the notes, into the recording last week. But I would say that is, once again, not only is it not required by me, it's not even recommended by me because it just adds to your memorization burden. So if you go to page 343 and you're trying to work some problems and kind of track along with what they do and you're comparing it to what I do, the bulk of what they do and what I do are the same. They just lay a little bit more of a burden on you in terms of memorization. So that's about all there is to that. Any questions about any of this before we actually work like a million problems that deal with this? Okay, questions will probably emerge more as we start seeing the problems. I decided this is, the integrated review probably deserves a couple of extra words of explanation, unfortunately, because I'd love to just be diving into working problems right now. There's a little bit, you know, I told you all the answers to the integrated review were in the back of the book. Yes and no. Let me be a little bit more clear about this because I had to figure this out for myself. Okay, so the integrated review starts out, as most things do, with problem number 1 and works up through problem number 8. And those are there's a problem in there. I don't even know how they expect you to do it yet. These are adding, subtracting, multiplying. They even throw dividing polynomials, which we haven't really done yet. Those answers are in the back of the book, and I'm just going to tell you, skip them. I will be skipping them. You should skip them too. They won't be on the test. Then the review gets a little bit confusing. It has examples like an ordinary textbook section and followed by a practice problem. And then it's got example 2 followed by practice problem 2. And then it picks up again with problem number 9 through, gracious, like number 56. These are the ones that are answers in the back of the book, and it's important to the practice problems. Let me check again. Sorry, this is taking so long as I was trying to figure it out earlier. Okay, we've got the review. Yeah, these. Sorry, what, Matthew? Yeah, I'll fix that after class, okay? These answers to the practice problems will be given in class. So just a little bit of a word about that. Yeah, the answers to question 1 through question 56 are in the back of the book, but questions 1 through 8 you should skip. And questions 9 through 56 don't happen until they throw in these practice problems that we'll do in class, and those answers will be provided by me. So it's a little bit, the organization in this section is a little bit weird. Okay, so starting with practice 1. Let me throw this out here and we'll just take this slowly and carefully. There we go. So in keeping with the two steps, one small one and one that I subdivided, let's just do a little bit of a quick review. Overall GCF, do you guys think there is an overall GCF? And if so, are you confident? Do you feel like you know what it is as we ease back into all of this?
Is it 4B?
Sorry, I turned my volume way down this morning. I heard you say a 4. What did you say after the 4?
Is it 4B?
Close. It's actually 4. Well, get my pencil back here. 4. Well, what did I do? There we go. 4AB. So yeah, the 4 is in there, the B is in there, and then the A's, you've got an A to the first here, and you've got an A to the second. And between the 2 and the 1, it's the 1 that is the smaller power. So that is immediately going to be incorporated into our GCF. So the B's were easy because they were both to the first power and you didn't have to worry who was smaller. But with the A's, you have to compare and contrast and pick the smaller of those two numbers, drop it down in there. So yeah, that's our overall GCF. And as I divide it out, here's going to be what the remaining pieces of the polynomial look like, and I have to introduce parentheses at this point. So I divided a 4 out of an 8 and got a 2. I divided a to the first out of a to the second, was left with an a. And then when I divide the b that's part of the GCF out of the b that was part of my original term, those just cancel. Okay, and then if you look closely before you start picking these pieces apart, notice that the 4AB, that is the second term, that is my GCF. So I'm dividing 4AB out of 4AB. I'm dividing a quantity out of itself, and that always just leaves a 1. Now, as a review, if you're not feeling confident with that division because it's been a while, you can always kind of physically place your GCF under a division line for both of those terms. And that can help you to think about the canceling. It can help you to think about if you need to apply the quotient rule for exponents, top power minus bottom power, stuff like that. So that's a really good technique. Now, we are left with 4AB on the outside and then 2A minus 1 on the inside. So this is where my step 2 comes into play. Count terms. And specifically, you can kind of ignore the GCF part of it. You had 2 terms to begin with, and you still have 2 terms. But you pulled the GCF away from them so you can ignore it for a while. So we're going to count the terms. Apparently, we've got 2. We had 2 at the beginning. We still have 2 at the end here. And So is this any kind of a squared minus b squared, a squared plus b squared? You can see as I'm starting to write these up that we really don't have squaring or cubing going on. So just a big no there. None of these end up panning out. And that's good news because that means our work is done. This is one of those problems where once you have pulled out, divided out the overall GCF, your work is done. Okay, so that's an example of best case scenario with factoring. That's as good as it gets. You didn't have to apply multiple rules within the same problem. Okay, so what was that? Practice problem 1. So that went well. Let's look at, you know what? I told you that was practice problem 1. That was actually not practice problem 1. That was example 1A. So let me fix that down here. Practice problem 1, part A, works very similar. It's at the bottom of the page, out of my line of sight here. It has X's and it has Y's. So we'll just use this as an opportunity to try the same thing again. Okay. Is there an overall GCF? And if so, what do you think that would be?
Would it be 3xy?
Yeah, it would. So let me put that over here, 3, the X and the Y. Thankfully, they're sticking very close to the pattern that they just had with the example. Okay, so I want to factor it out. And then whatever remains, okay, so the 3 goes into the 12 and leaves a 4. The X's, well, I've got X to the second over X to the first, so top power minus bottom power leaves me 1X. Y's cancel. And in the second term, just like last time, 3xy cancels with 3xy. And that leaves me counting terms. And just like before, I'm focusing on those leftovers. There's 2, but no further factoring can be done in this case. Okay, so let me box that in. That means the answer. You did, very good. That's my answer. Okay, now let me try to actually stay in practice problem 1. Okay, so that was part A. Well, it will be when my timer goes off in about 15 minutes. Okay, so here we go. Okay, and it's easy to start going, I'm seeing 2 terms, what do I do? But let's not think about that quite yet. Is there an overall GCF? And if so, what is it?
Is it an exponent?
Well, in this case, tricky problem, there actually is not an overall GCF. So we could say except 1, because there, you see x squared, that's our only exponent in the whole song, but the other term doesn't have x to any power, so we can't include the x's. And then when we look at 49 and 4, there's no number that divides into 49 and 4 except 1. So that means we can skip the overall GCF step and go on to counting the terms, and pretty obviously, there's 2. Okay, so when there's 2, of course, I've got my 4 choices. It's either a squared minus b squared, a squared plus b squared, minus b cubed, and plus b cubed. And I am seeing automatically an x squared here. So I'm going to say probably. Okay, that looks like our best bet, but we want to make sure that we can rewrite 49x squared minus 4 in that format. Okay, now 49 and 4, after you've done a few of these problems, numbers like that will start jumping out at you because 49 is 7 to the second power, so we call 49 a perfect square. And then 4 is 2 to the second power, also a perfect square there. So every single thing in this problem, the x to the second power, the 49 and the 4, all of those are something to the second power, which means that this formula that we said probably is looking more and more likely. In order to get it to work out, though, we need to do a little bit of extra work here. Okay, so inside the first set of parentheses, I'm going to put a 7 and an x. Because if I square that out, the 7 squared would turn into my 49, and the x squared would turn into, well, x squared. And then in the second set of parentheses, a little bit simpler, I probably didn't even need parentheses because there's only one thing that goes in there, and that's a 2. So being really careful, if this is this is like a squared minus b squared, what that formula tells me to do is just pull a and b themselves out of there and place them one time separated by a minus, one time separated by a plus. So what I'll do is just, I think we can do that here. A minus b, a plus b. And I can box that in. So A, so-called, was just the insides here. This was A. And just the insides here was B. So A was a kind of a 2-part A. It had a 7 and an X inside of it, but they were stuck together using multiplication. So that means that they are really one thing. And then they were squared to form that 49x squared. Okay, so that was an example where there was no GCF. We just dove straight into our memorized formula. Let me do part C here. Whoops, and I'm about to do the same thing I did earlier and look at the wrong problem. So 5x squared plus 2x minus 3. Okay, so we're probably already going, I see 3 terms, but before we worry about that, is there an overall GCF? And if so, what is it?
There is none. There.
Yeah. No, except for 1. So I count the terms. And there are 3 terms, pretty obviously. So that's going to trigger that AC method where we take our 3 terms and we expand them very carefully into being 4 terms, so that when we have 4 terms, we can do factor by grouping. So it's been a couple weeks since we did this. So remember that the A and the C, if you have your polynomial organized in descending order, which they usually do for you, so x squared term goes first, x to the first term goes in the middle, and then no x's go on the end there. Okay, so here's the A. And here, including that negative, you always take the sign that precedes the number as part of the number in this. So we go A times C, that's going to be 5 times -3, and that's going to give us a -15. Okay, now with -15, we have to think about all the ways that we could multiply two numbers and get a -15. So we could have like 1 and -15, or we could also have the 1 being negative and the 15 being positive. And because it's been a while, I'll kind of go through this with a couple more terms. 2, we had 1 goes into 15, 2 does not go into 15. So the next thing we get to write down would be 3. 3 times -5, or -3 times 5. 4 does not go into 15, but 5 does, but we already handled 5. So when you see those matching factors, you can actually kind of cross that out. You don't need to go that far. That's extra because it's really just the same numbers. So we have two lists here. And if we look at adding together the members of each pair here, notice that the first list, the one on the left, will always give us a negative. So if I took 1 and I added it to -15, I'd get -14. If I took 3 and I added it to -5, I'd get -2. But what I'm trying to do is add together in such a way that I can generate +2. That's going to be my ticket to being able to expand this problem. And the only way I can do that apparently is off of this second list, because it's the second list that if I were to add members of the second list, I would always get a positive. So what we were in the habit of doing a couple weeks ago when we had worked a lot of these in the row, as soon as you can recognize that one of these lists will never give you the positive number that you need, just go ahead and cross it out. Okay, so, and again, here's how we know that we picked the right ones. -3 plus 5, that's the +2 that we need. So that's going to be what we break apart. So the next part, 5x squared. Oh, thank you. Can you put them on the chair for me right now? And I'll get to them later. Thank you. So instead of +2x, I'm going to have -3x plus 5x. And then I will have -3. So now I've taken my 3-term polynomial, I've expanded it to being a 4-term polynomial, and I'm going to divide that in half. Okay. So this will mean we need a GCF from the first 2 terms, and then some leftovers. We need a GCF from the second 2 terms, and then some leftovers. If you want, because we're trying to get this all the way down till we have the problem completed with a couple of sets of parentheses like that. If you feel confident in this, because I know it's been a while, see if you can get from these 4 terms down to the end of the problem. And if not, or if you get stuck, just let me know, because I'll be filling in the steps for you guys in the notes in a minute anyway.
This is a great one.
Okay, I got it. It is x plus 1, and then in the next parentheses, 5x plus 3.
That's very, very close to what I got. I think, let me write this down. I think it's 5x minus 3. Let me fill in a couple steps and.
That's what I said, or I meant to say that.
Okay,
The first
great.
one's positive, the second parentheses is negative.
That is perfect. Okay. Okay, so yeah, the GCF of the first two terms. It did. Okay, so I will turn that on for you in just a second, okay? So there's the step where you had positive GCF here, and then that got you down there. Okay, great. Okay, so the next problem, interestingly enough, goes a little bit backwards in time and throws 4 terms at us. We don't think about that quite yet until we've established that there is no overall GCF. If you tried x to some power, the 6 all by itself would throw you off. If you tried 2 or 3, this term here, x cubed with a 1 in front, would throw you off. So there is no overall GCF except 1. Okay, so that has us counting terms. And we see 4 terms. So automatically, the only thing that we can try is to factor by grouping. So let me rewrite this down here. So when I fill in the gaps in the notes, so that was 3x squared plus plain 6 plus x cubed plus 2x. So this is about where we were a few minutes ago in the other problem when we had to expand. Do like that. Okay, once again with this, see if you can complete this factor by grouping 4 terms. GCF from the first 2, GCF from the second 2, and eventually you would get down to something that looks like that.
Salty nuts.
Okay, the answer is 3 plus x, and then x squared plus 2.
Yes, that is exactly what I got. Let me get back then. Oops. Too much technology at once. So to fill that in, there was a 3, and then x squared plus 2, and then plus, so this GCF is positive. X squared plus 2, they match, and then one order or the other, either the 3 plus x first or the x squared plus 2 first. Okay, so great job with that one. So there were 2 back-to-back problems that kind of relied on the same ending to the problem, but the way they started was different because of the different numbers of terms. Okay, part E here. 4x squared plus 20x plus 25, back to 3 terms. And I'll just go ahead and do this part. Yes, there's an overall GCF. No, oh, wait, no, there's not. There I am opening my big mouth. That 25 throws it off. I was like, oh yeah, the 4 goes in there. Nope, does not. Apparently I was writing it down without reading. So we've got, once again, this is going to be interesting then. Let's see. Okay. So we count the terms, and there are 3. So that means we want to use the AC method, which requires us to expand that middle term so that we're able to factor by grouping. So let me rewrite. Thankfully, everything is positive. So that's going to make our job in one sense a little bit easier. In another sense, not so much, because the A and the C give us 100. 25 times 4 being 100. So we're going to factor it, start factoring 1 times 100. See if you can find the correct 2 numbers that multiply to be 100, but that also add to be this positive 20 here in the middle, since positive 20 is what we want to break apart. So just take your time. I did the 1 times 100. So next will be 2 times 50 and so on. See if you can find the 2 terms there, the 2 factors, I guess I should say.
I couldn't find any like factors other than 1 times 100, 2 times 50, and 4 times 25. And none of those made the right number.
You're right, they don't. But there's actually another pair. So 2 times 50, 3. So we got 4 times 25, 5 times 20, I guess. No 6, no 7, no 8, no 9. But there's actually 10 times 10, and that'll do it. 10 times 10 is 100. And then 10 plus 10 will give you 20. So it's literally like the last pair of factors that you would come to. And it's in between the 5 and the 10, there's just a string of things that don't divide at all. So it's easy to miss. So 20x here is 10x plus 10x. Okay, so that gets us right back to where we were. And there's something interesting about this problem. So let me get us to the end here. So positive. And then I didn't do that over here. Notice that as you complete this problem, you're going to get a bunch of repetition. In fact, you'll get 2x plus 5 twice, which you could leave or you could write as that, either way. When that happens to you, that is a case where the book wants you to recognize one of those optional formulas to memorize. Book would want you to recognize that this is an a squared plus 2ab plus b squared formula, which always factors down to a plus b, the way you would recognize that, which is kind of not always ideal. Get this recopied. You would recognize that 4x squared could be written as kind of like what we have to do with our squaring and cubing formulas. And then the 25, similarly, that could have been 5 squared. So if you recognize that the very first term is a perfect square and the very last term is a perfect square, and then maybe you can recognize that 2 times your first term times your last term would give you your middle term. 2 times your first term times your last term. You could force this into the a plus b squared. Again, that's not required and it's not ideal. For one thing, it lays more memorization on your plate. For another thing, it looks way too much like part of the sum or difference of 2 cubes formula that you do have to memorize, which is very much like this, but without the 2 in the middle. So I'm just gonna throw a note in there. This is what the book would want you to do. I don't care if you do that, but in a way I don't want you to do it, because you can get there the same old way we would normally do with the AC method. And it lays, to me, it leaves for maybe fewer pitfalls down the road. So, but just bear that in mind in case you are interested in doing it the book's way at this point. And then part F here, one of the best problems ever. I almost don't want to force myself to go through our little routine because I can see where this is going. Overall GCF, nope, except 1. And then 2, count those terms. And we see 2 terms, and that automatically tells us if this is going to factor, it's going to be a memorized formula. And the possibilities for the memorized formulas, there's a squared minus b squared, a squared plus b squared, and then the cubes. And it looks to me, because 100 is 10 squared and b squared is b squared, these are both quantities to the second power. It looks like we've got this one, but the good news is when we have this one, the answer to our question is literally going to be the word prime, or the words not factorable if you prefer. This polynomial, because it's in the form something squared plus something else squared, I know it's tempting and it looks like it should factor, but it absolutely doesn't factor using the current rules that we've been given in algebra. So spoiler alert, later on down the road, there's a way that you can force this thing to factor, but it requires us to use what are called imaginary numbers. And we're not there yet. That's one of the last concepts we learn for the entire course. So the answer to this problem, this is best case scenario. There's absolutely no I guess we can't say really there's no math to be done because we did have to kind of break apart that 100. But really, there's no factoring to be done, no method to be applied. It's just requiring us to recognize that fact that there is no work to be done. Okay, that's the end of practice 1. We're definitely going to get practice 2 under our belts because that is just more of the same in terms of just applying those factoring rules over and over and over again. And so, of course, there is an example 2 that goes along with this that you're welcome to read. Practice 2 is what I'll do in class so that you can have the answers there. And I am kind of looking ahead. The integrated review is very long. In fact, we'll probably end up using it really as our test review. And I'm thinking there's a couple problems I'm going to knock off of it too, just to, yeah. Okay, before I get distracted with that. So first problem here in practice 2. All right, yes, 2 terms coming our way. But before this, overall GCF. Nope, except 1. Okay, now counting the terms. And we had a bunch of these in one sense in the last practice problem because we're always counting terms and getting 2. I think we had 3-ish problems. Yeah, we had 3 problems with 2 terms last time, but this one's going to function a little bit differently. So just starting at the top of the list, if we've got 2 terms, our only hope of really being able to do anything is if we get one of these 4. Now, just off the top of your head, and I'll number them to hopefully make it easier, because they don't really have catchy names. Sum and difference of 2 squares, or sum or difference of 2 cubes. 1, 2, 3, or 4, which of these formulas do you think that we have here?
It's number 4.
Yeah, it is number 4. This is what we've got. So we get some practice. Always good to get practice with this because this is, to me, some of the trickiest parts of factoring. All right, the x cubed and the y cubed parts aren't too difficult to wrap our minds around. But what we also have to figure out is if this is going to work, then 64 has to be some number to the 3rd power. Can anybody think about what number to the 3rd power 64 is?
Is it 4?
4, yeah. I'm going to be a little weird because we're used to thinking of 64 in terms of squares. It's 8 squared. Everybody likes that. But it's also 4 cubed. So you'll see 64 in a lot of problems because it can do double duty. So we've got the quantity 4x to the 3rd power. And then y to the 3rd power. I'm going to put it in parentheses just to emphasize as we're setting this up. The insides here of our first set of parentheses, that's A, so 4x is A, and the y is B. Okay, so the formula, A cubed plus B cubed. Okay, so A plus B, same sign as was in the original problem. And then in the second set of parentheses, we have an A squared. Then the opposite, so same sign, opposite sign, and then always positive there at the end. Okay. Now, this will probably, just because these are more complicated formulas than the squared formulas, I'm going to plug what I have in to that formula, but it won't probably be the final answer quite yet. So The a plus b part, that's pretty simple. That's just 4x plus y. But then it gets a little weird, and I might actually just, for clarity, I'm having to do an a squared there, so little parentheses in there, minus an a times a b. Maybe don't need parentheses there, but we'll see. And then b squared. So I'm being extra cautious and just throwing parentheses around everything, because some of that will take some more simplification if I'm going to leave this in kind of a typical nice looking algebraic form. So if we get lucky, applying the formula is all we have to do. This problem, not so lucky, because we have to apply the formula correctly, of course, and then we have to clean up. So the quantity 4x to the second power, that's going to give us a 16x squared. 4xy in the middle, thankfully there, the parentheses didn't really help us out at all, because 4xy is just 4xy. And then y squared at the end. Similarly, you could kind of just pull the parentheses away. So really, it was that quantity 4x to the second power where we really had to make sure that not only did we plug that into the formula, but we went one step farther and simplified it out. Okay, so, and I think I might have mentioned in the recording that one of the weirdest things about these particular problems is learning to correctly pull a and b out of the formula. We're given a to the third and b to the third, and so common mistake that I see people making is to do something like this. Just pull, instead of a plus b, try to do something like that. And but you really do have to take that time and pull a and b out, because they are the building blocks. They're what you need to complete that formula. So this is a good example of what to me would be, and take this with a grain of salt because everybody's different, but I always find, just from a student's perspective, as well as me as a student's perspective, this is usually like the hardest problem on the test. Something like this, where you're applying a memorized formula and it's got some hidden stuff in there. It's not just saying, well, X is A and Y is B. No, you have to break apart the 64. So this is, to me, as hard as it gets on a test about factoring. So maybe that's good news, maybe that's bad news. I just feel like students tend to experience more success with the stuff we were doing earlier. Were you raising your hand, Sarah?
Yes. I'm just confused about why it's 16 in the answer, how it got there. Can you just tell me how it went from the low parentheses to the bigger one? That's the only thing.
Yeah. The little parentheses, so if I come up here, 4x squared, a couple of ways you could look at that. That is like, you can apply the 2 to the 4 and the 2 to the x like that and get there. That's an exponent rule we learned. Or if I kind of back off on my arrow here, you can think about 4x to the second power as 4x times 4x. And in that case, you'd have 4 times 4 would give you the 16. And then you'd have x times x would give you the x squared. One way or the other. Does one of those look like it makes sense? And yeah, it's kind of weird because nothing else in the problem really requires that same level of just thought. The 4xy there in the middle and the y squared at the end don't do the same thing. It's most similar, I guess, to what we were given at the very beginning, where 64x to the third is the same thing as the quantity 4x to the third, because that would be 4x times 4x times 4x. 4 times 4 times 4 gives you the 64. X times x times x gives you the x cubed if you're kind of reversing the process and making sure that you broke this thing down properly. Trying to think if there's a better, I might superimpose, I had this down at the bottom, but because we ended up having to simplify, let me superimpose the formula itself once again, kind of up here. There's a plus b, there's a squared minus ab plus b squared. So you can kind of piece together what goes where. Okay, part B. I was kind of looking to see if they threw one that was similar. Part B is definitely not super similar to what we just did in part A though. Okay, so in this problem, do you think there is an overall GCF? And if so, what would that overall GCF be? For the first, I'll just go ahead and tell you there is an overall GCF for the first time in a little while. What do you think it would be?
It's 7y.
It is 7, yes, but it's actually going to be.
Is it 7y squared?
Yeah. When you're comparing the powers of y, you can take the smaller. So there you go, 7y squared. And let's see what that thing looks like when we pull or divide, I guess I should say, divide the 7y squared out. So if you want, we've done that a minute ago, you can actually show the division there for your own benefit. Okay, so let's see. My head just exploded there. It's x squared, yeah. 9 y squared. X squared minus 9 y. Interesting. Huh. Okay, I see what they're doing. Count the terms. And again, when there's an overall GCF, as we count the terms and try to do something with those terms, we're really just ignoring the GCF and counting what's in the leftovers or focusing on what's in the leftovers. So 2 terms, so we've got 4 choices. Which one do you think this is?
It's the first one, right?
It's the first one. Yeah, exactly. So maybe not everybody's favorite. I think the prime one's probably everybody's favorite, everybody's second favorite. So let's see if I carry this down, and I want to be careful that I don't neglect, even though it's not going to contribute to my factoring, I don't want to neglect that 7y squared that I've got sitting here. Okay, so I am going to kind of pull this part down and work on it separately. So I've got x to the second power. And then because 9 is 3 squared, I can rewrite so that I'm able to see what b is. Anytime you've got a two-part thing, you've got numbers and letters as part of an a squared or a b squared, you've got to kind of put that parentheses there. If you want, for consistency, you can put it around the x as well so that you can see that inside you've got x playing the role of a, and you've got 3y playing the role of b. So this is like a squared minus b squared, if you want to see the whole thing together. So a squared minus b squared, by memorization only, there's no way that you can really get here using like the AC method. A minus b, a plus b. Easiest formula that we have to memorize. Nothing is, it's not like the cubed formulas give us always something squared in their parentheses. But if you're starting with a squared formula, it breaks it down and gives you everything to the first power. So we've got a minus b, a plus b. So not only is that the easiest formula to memorize, it's also, and I said I was going to not forget my GCF and then I forgot it. It's also the easiest one to check your work. It's pretty simple to distribute all of this out by multiplication and make sure that you're correct. So let me draw the line and put the words in that I was doing in the notes a couple weeks ago. You don't want to forget that 7y squared, as I just did. And then the result of our difference of two squares looks like that. So all together, this is what we have. Okay, getting to the end of these practice problems. Yeah, I think we can finish this off with in time for the end of class. All right, so back to a 4-term. But before we start thinking about, hey, that must be factored by grouping, let's ask ourselves about an overall GCF. There is an overall GCF. What do you think that would be?
Sorry.
It's 3.
It is 3, yeah. So no X's or B's as part of that. Okay, sorry. 50 things going on. So if I pull out the 3, what I have left is x squared plus 4x plus 4 minus b squared. So probably the easiest job of pulling out a GCF that we've had in a while, because we didn't have to mess with exponents. We just literally did normal numerical division. And second part here, count those terms, and of course, there are 4 of them, as there were to start out. So that means our only option is to factor by grouping. Okay, and as I do that though, it looks like I'm off to a promising start because I'm able to pull an X out of the first couple of terms. But notice that over here, I run into problem. Basically, that B term is going to throw everything else off, and it doesn't matter how I try to, in my mind, I'm restructuring all of these terms, but it doesn't matter how I rearrange where I put that b squared, it's always going to be a problem. So let me erase this and let me add something that I added back at the beginning of today's discussion when we were first. Remember, it's always an attempt, but it's never a guaranteed result. You can try to factor by grouping. You can try to pull things out. Are you okay with that? Okay, good. You can try to rearrange these. I will never throw one of these problems at you, and it looks like the book won't either, where you actually have to rearrange the term. But just bear in mind, in a higher level class, they sometimes do give you four-term things that appear to not be factorable, but that really are if you just pull a couple of terms in a different order. But in this case, that b squared throws everything off. So we try factor by grouping, but it doesn't work. We're not able to get, and so let me just complete the thought that I was talking about. This is what we're getting. We're getting non-matching terms in those parentheses after we pull out our little GCFs.
What's a wafer?
What?
What's a wafer?
Oh, it's up here. So for us, really, pulling out that 3, as sort of weird and unfinished as that feels, that is finished for us. So yeah, we'll just count our blessings on that one, because normally we would have had a whole lot of things to do with these 4 terms, but there's nothing we can do. So the GCF was it. Okay, getting down to the end. Okay, so, whoops, here, I'm a little messy, so that's what I'm trying to do. Let's get another shot at finding an overall GCF. There is an overall GCF here. What do you think that overall GCF would be?
How do you erase?
Is it just XY?
It is yes to the Y part, no to the X part. Try again with the X part.
Is it because it's the lowest one? It's just x2, right?
Yeah, that's it.
X squared.
Here, the 2 and the 5, grab the 2. And then in a way, you were comparing a 1 and a 4 with the Y's. So yeah, we've got that. Let me kind of put that under here. And put that under here as we divide it out and see what we're going to be left with. Okay, so this is a good opportunity to practice a little bit of exponent rule stuff. When you've got x to the 5th divided by x to the 2nd, top power minus bottom is going to leave you x to the 3rd. And then with the y's, y to the 4th over y to the 1st, 4 minus 1, top power minus bottom power gives you this. I've got a 27. Looks like my x squared cancels with the other x squared, and my y to the 1st cancels with the other y to the 1st. So it's kind of good news there in one sense. In another sense, I see what they are doing and where they are going with this. As we count the terms in what remains, and we see that there are 2 of them, and of course that always triggers 4 possibilities, and the nice ones are off the table because they're all relative to squares, and we obviously have cubes. And specifically, we have an a cubed plus a b cubed. So let me rewrite. They're not going to let us get through today without doing another one of those. X cubed, y cubed plus 27. Okay, so 27, what number is 27? What number to the 3rd power is 27? Let me rephrase that.
It's 3.
Right. So my rewrite step here to make this all work out, this is a cubed plus b cubed. So I have to figure out what's a and what's b. A is just xy, because xy to the 3rd power is the same thing as x to the 3rd y to the 3rd. There's an exponent rule from way back in the dark ages that told us that that's true. And then 27 is just 3 cubed. So we can say that reaching inside here, a is a quantity, it's xy, and b is just this number 3. All right, and then for my benefit, I'm going to say, don't forget that GCF, because I totally forgot that GCF last time. All right, so the formula, let me think, what's the best way to do this? A cubed plus b cubed is a minus b times a squared plus ab plus b squared. And I always try to do that if I am using really good habits. Just write out the formula that you're going to need. Don't try to plug in quantities as, you know, without writing this down first, because it's hard to kind of like stick things into something in your mind and then get it on paper. So what I'm going to do carefully here, I've got a minus b. Okay, so make sure you understand why that's a and why that's b. And then I'm going to have an a squared plus a times b, and I'm protecting them in parentheses here just in the hopes of being slightly clearer, if that is even possible with this messy of a formula. Okay, so just like before, we have one of those confusing things where we have the quantity xy to the second. That's the same thing as just x to the second, y to the second. Again, that same old exponent rule from way back when allows us to do that. There's nothing mathematically wrong with here in the middle, x, y, 3. It's just that typically in algebra, we're taught you stick that number in front of those letters. So you haven't done anything dramatic. You've just rearranged so that your number goes out front. And then 3 squared, of course, is 9. Okay, and as I had attempted to remind myself, this whole problem is still going to be led off by the x squared y that was our GCF. And then everything that I had right here okay. and seeing, looking at that. For one thing, we're almost out of time. For another thing, I eyeball these problems. And one said, this feels a little bit silly to say that part E is too hard because part D was plenty hard, but I am going to call it right there. Conveniently, we're out of time, and just seeing kind of what they put us through there, like I don't think we need to study ones that look like part E. So, okay, as a recap of what we did, we reviewed everything that we know about factoring today. Now, that is not going to be our only review because as we get closer to the test, there will be a test review. Let me reiterate here with the homework, because your homework is really more review. You've done homework on all of this stuff. The rest of the integrated review, and I'm kind of leaving this in your ball court in terms of what feels most comfortable to you versus what you need the most work with. The integrated review, problems 9 through, and there's a ton of them. So this is like probably aim to have looked at these prior to the test, not prior to Thursday. 9 through 57, but I'm going to have you omit a few because I was eyeballing them as we were going along, kind of seeing what they did. It's more of the same of what we did today. They just throw as much factoring as they can think of at you. Okay, so you can omit all of those. That's just too much.
Wait, what section is this?
The integrated review is what we were working on today. It's page, where does it start? Page 343 through 346. So it's a section that falls between 6.7 and 6.8. They conveniently like stick this review section after 6.7. So we went ahead and just used it today instead of learning something new. So the integrated review, and then from the actual end of chapter review document, I know it's confusing, there's reviews upon reviews. The problems included in the document that I will send you by email in a minute. I'm sending you the answers. And these are only problems for 6.1 and 6.2. So 6.1, 6.2 was an age ago. That was exponent rules. So I wanted to give you some problems to start reworking. If you feel okay about the factoring, you can leave this integrated review that we were talking about, that we did some of today. You can leave the rest of that for later, closer to the test, and focus for the next couple of days on some of this old stuff, 6.1 and 6.2. I've sent you the answers, or I will send you the answers. If you feel that you were really great with 6.1 and 6.2 and you want to just stay in the world of factoring and do more of what we did today, you can do the integrated review. If you want to do some of each, just to kind of throw it out there, because by the time we take the test, we will have talked about most of the problems from the integrated, most of the problems from the chapter 6 review that you will need. So I just wanted to kind of give you a foretaste, like you can start working on that, because I'm not assigning true homework. We didn't learn anything new. We're not doing an actual section. So I know it's confusing. It's a lot to take in. Remember also this 6.1, 6.2 stuff, when I do get to where we're actually doing a test, that's going to be an open book part. So the only part that you will need to close your book on will be like the factoring that we did today, and then whatever we learn on Thursday. So I will be so glad when chapter 6 is done. Chapter 6 should have been like 2 chapters. So in retrospect, maybe we could have broken it up different, but you know, live and learn. So, okay, we have gone overtime. Let me go ahead and get this recording posted up on the YouTube thing and try to send you guys that document. I'll see everybody on Thursday.
Bye.
Thank you for
Thank you so
class.
much.